Hey, today I'm going to demonstrate A2A, agent-to-agent protocol, and MCP model context protocol. And I'm going to discuss some of the security implications there. So first off, in our architecture today, we're going to have a client connecting to a remote A2A server that has access to a local MCP server and also a remote downstream MCP server. So we can go over some of that code here. Um, The MCP client, you can see this intelligently will dispatch requests to different remote MCP servers or its local MCP server. And this is basically remote procedure calls. And the MCP client is what is AI enabled, and that is going to intelligently route. Uh, it's going to intelligently connect these different tools together. So you can see the prompt here. It's told to do that orchestration, but if the request is irrelevant or it can't be fulfilled with the tools that it has, it's going to just return blocked. We can see here that we're configuring it with a math MCP server, which it requires a bearer token to authenticate to, and also a string MCP server, which is just local, uses standard IO, and does not have any type of authorization. So here is the string MCP server. We can see we have three different tools: an echo tool, a reverse tool, and a length tool. Over here, we have a math MCP server, and this does require bearer authentication to connect to it. This uses HTTP as the transport, and it defines three tools: an add, multiply, and a math tool works tool, which is going to return this special value so that we can confirm that we're able to call that tool and that the math MCP server is being invoked. So let's look at the A2A server. So here, A2A, we have different skills. So we have a string skill and a math skill. So when a client is deciding whether it wants to use an A2A server or not to fulfill its request, it's going to look at what skills it's advertising, the capabilities here and the skills here. Um, so here, the agent card is what is going to be publicly advertised. So here we're advertising to people potentially on the internet that we have a Python helper tool, and it does helpful things with Python. So A2A, it's not going to use remote procedure calls. It's going to be much more unstructured, where you can use natural language to delegate certain tasks to A2A servers, and they're going to communicate potentially with other A2A servers to fulfill your request. So here we have a public agent card, which anyone can call, but we're also defining a security scheme where you have to have a bearer token, and then that's going to allow you to use this authenticated extended card. So the authenticated extended card is going to, in addition to the string operations, it's going to advertise its math skills. Um, when this A2A server is invoked, it's just going to go ahead and invoke the MCP client with that user input, and it's going to pass along the bearer token. In real life, you would want to probably have this A2A server get a new bearer token, and then that with that containing context about the user, and then pass that along to the MCP server to authenticate. But in this case, we're just going to go ahead and pass along that bearer token that we receive. The reason we're doing this is because we want to preserve user context to the downstream systems so that that downstream MCP server, it can decide whether it wants that specific user to be able to perform the functionality and not just trust the A2A server. Because it's possible that I am authorized to do a particular action on the MCP server, but somebody else might not. So we don't want to be open to a confused deputy attack in that case. Um, so yeah, and then also we require a bearer token to authenticate to our authenticated extended card endpoint. So here we're going to run our test client here. So first off, we're going to run it with no authentication. So we're going to get an error when we try to access that extended agent card, but we're going to fall back to the public one. So this is the agent card we end up using. So we have just the string operations that are defined here. Now, if your downstream MCP server did not perform its own access control and just trusted the A2A server to, then this skill advertisement, this would not be any sort of access control. It's just so that clients can decide whether they want to use your A2A server for certain operations or not. So if we got this advertisement talking about just string operations, but we decided to go invoke that math tool works function, we would still be able to successfully execute it. But we're going to ask it how many letters are in the word fire truck, and it's going to call that string that length function, and it's going to fulfill our request, and it's going to give us the answer there. Next up, let's call invoke math tool works, and let's see what happens. We're going to get that response blocked. The reason for that is because we instructed our MCP client to basically block any requests that cannot be fulfilled with the tools that it has access to. So next up, let's query it with an invalid bearer token, and let's see what happens there. So this is invalid because we garble the last two characters. So let's see what happens. Here, we get the same agent card back. So we do not get that extended agent card. We just get the basic one talking about the string operations. But when we try to invoke the math tools, we get a server error because it's trying to invoke that math tool works function, but it's not able to authenticate to the downstream MCP server. So it successfully performs that access control and prevents us from calling that function there. Lastly, let's use a valid bearer auth token. So here uh, we're going to actually get the full agent card back. So we can see here, this is the extended agent card. It includes skills around the math operations. So when we call that, we ask it to invoke math tool works. We get that response back correctly. So it says, let's actually say invoke math tool works and return the number it gives us. There you go. So it says the number returned is 1234, 1234. So we can also use this. Let's use this to perform some orchestration between the different components. Um, how many letters are in these words? Add up the total. Fire truck, dolphins, turtles. Okay, let's run that again. And now we can see it orchestrating all of these different tools together. We can go into our server here. So we see it's calling length on these different words using the string MCP server. So it's calling length on those different words we entered. And then we can see that it is calling add. So it's adding together the lengths of these two words and then the lengths of that sum and the third word. And then we get this response back, the 24. So that's how MCP and A2A work. That's how you can use a A2A server to handle natural language user requests, and how you can use it to an MCP client running on that server to intelligently dispatch requests to various MCP server tools. And lastly, we're showing how you can securely authenticate users by providing user context to the downstream MCP server, which then will perform its own access control there rather than trusting the upstream A2A server to do that authentication. Now let's see the communication that is occurring between the MCP client and the LLM. I've instrumented the MCP client to log the HTTP messages that it's sending to OpenAI, which is not normally revealed to you just by using LangChain's default logging. So we see here that the value that is being sent to OpenAI, it's post request, and it includes the system prompt, the user prompt here, and it also includes a list of tools with descriptions, names, and parameters. This is the response from the LLM to the MCP client. So this is instructing the MCP client to call the length function on these three different arguments. So calling the length function 3 times on each of these corresponding words that we asked it about. We scroll on along. The next communication from the MCP client to the LLM, it includes those previous tool call instructions from the LLM, and it also includes the return values from those, so 9, 8, and 7. Um, Now, based off of that second query, the LLM is going to tell us to make more tool calls. It's going to tell us to call the add tool on 9 and 8. So we're going to similarly pass that return value here with the response from the tool, which is 17. And then the LLM is going to tell us again to call the add function until lastly, it is going to eventually tell us that it has finished. It has a result for us to return to the client, and that we receive right here from the A2A server. And that says that the sum of those word lengths is 24.